This is a short demo of a prototype that allows live coding a filter written in the Halide imaging language in the Atom text editor. I created this package because I was working through the various Halide tutorials and found that I wanted a faster way to see the results of my tweaks to the code and input parameters. I included a few examples in this package, and so I'm going to pick one of those now. It produces a very simple checkerboard with parameters for the size and for the shade of gray that's used for the blocks. So now if I go into the menu here and toggle on this preview mode, it's going to show me an example of the output of this filter, and I can fiddle with the parameters within their ranges, change the size. Now if, for example, I wanted to be able to support rectangles instead of just squares, I could change this to width and height, and have the x divide by the width, and the y. Same for the height. Now when I save it, it's going to rebuild and rehook this up, and now I can change those parameters independently and see the feedback of that change very quickly. Or if I wanted to change this to be different defaults, I'll also refresh. You can see what that gets you. So it's a pretty simplistic example, but you can kind of see how you can sort of play with the algorithm and the parameters to it a little bit and get very fast feedback. So another example of doing this, let's do the same thing to, I've already split out height and width. I was just using an expression to make them the same before. So I can change this and have a separate height and width parameters. You can also see, when doing this, the effects of the scheduling choices you're making. In this case, we see the schedule is bad and only gets worse as you go into larger block sizes, because I'm no longer reusing the computed value for each tile. So the larger the tiles get, the more grossly inefficient that gets. But if I put that back, now we see I'm back up to a very zippy frame rate. This is only a 600 by 600 preview, so it would be a little slower if it was a larger preview, but you can still see the relative magnitude differences here, where frame rate collapses pretty severely. Another example that I found within the tutorials for Halide is this example of using tuples to render a Mandelbrot set. And I found this example, and I don't really know the math behind it well at all, and since it's just a simple example, it doesn't bother to parameterize the inputs here, so it's a lot of relatively hard-coded numbers, and the number of steps and thresholding and all that is also fixed. So I took this example and tweaked it a little to fit it into the format that's required for this package, and came up with this, which I then took all those numbers and lifted them out, gave them reasonable ranges, or interesting ranges at least, and names, so that then you can see you can fiddle with different aspects of this and have the sliders there to quickly modify them. You can also kind of see what happens as you're playing with parameters to see what effect they have on the behavior. So it can be a very interesting way to do sort of exploratory experimentation with a algorithm you either don't really understand all that well, or one that you do and just want to explore, making it more flexible by adding parameters that control different aspects of its behavior. So another example of that, I could go in here. Here I've got a couple of properties, so I'm going to change this to a new parameter and make it a float, since the original value is also a float. We'll call it, I'll just call it WB, since I haven't told you what it is yet. And we'll have it go a range from 0.0 to 2. And now we've got the slider, and we can fiddle with it and see, oh, I see what that's doing. That's just a kind of a dumb multiplier to control the brightness of the water. So we can then call this water brightness. And now when it refreshes, it shows up as such. Similarly, I find sometimes it's useful to be able to drill into the other outputs of a pipeline and see them. So in this case, we can see that in the last step in this algorithm is to turn the fractal noise it's producing into a colored value that makes it look like a map. But instead, if I want to see the raw grayscale input, I can do this. And we'll see here that because this level of the sort of call structure doesn't use several of the parameters, they no longer appear over here. You can still fiddle with the seed, you can still change tile width, or in this case it's effectively a zoom factor, but you'll see that the parameters that are unused are no longer present. Another thing you could also do is look at the specific noise at a particular level, since it's adding together noise at different frequencies. So, oops. Levels. There we go. And now we can actually look at how we add all these different noise levels together and what those look like individually. So anyway, I find that kind of interesting when I'm, again, playing with an algorithm and trying to understand it better. So I guess that's about it. It's just a quick tour of what's possible. It's a fairly simple environment. It's constrained a bit in terms of what kinds of filters you can do at the moment, but I found it really helpful when I was learning this stuff, so I thought I'd get it out there and share it. Thanks.